Welcome to Brain Vision.
For this problem, we want to determine how long it takes for a certain amount of mass of sucrose to travel through this sucrose in water solution here in this cylinder. Given that we have the geometry of the cylinder, the diffusion constant, and the difference in concentration from one side of the cylinder to the other. So what this is an application of Fick's law of diffusion. And specifically, that is going to be that the mass transferred is equal to the diffusion constant times the cross-sectional area of our cylinder times the difference in concentration from one side to the other divided by the length from one side to the other times time, the amount of time that passes. Okay, so we want to figure out how much time it takes for a mass m to be transferred. So really we want to solve this equation for time. So we can multiply both sides by L over dA delta C to move this over to this side. And we will have L times M over D times A times delta C equals T. All right, so now we know what L is. I mislabeled it there. We know what the cross-sectional area is. They're both in meters, so that's good to go. We have the concentration difference, the mass transfer, and yeah, that's everything actually. And the diffusion constant. So we should be able to just plug these values in now. And if we do that, we will get that it takes 11.4 seconds for us to transfer 8 times 10 to the minus 13th kilograms of sucrose. So there you have it. We just determined that it takes 11.4 seconds to transfer a certain mass of sucrose from one end of this cylinder to the other, given that we know the geometry of that cylinder, and also given that we know the concentration difference of the sucrose in the water from one side of the cylinder to the other.